professor, and I also have a position as a research scientist at the Institute for Human and Machine Cognition. And I do different projects. Depending on the project, I'll do it with a different hat on, I guess you could say. So, let's see. Before I begin, I always like to thank our sponsors because it's really our sponsors that make this possible. So the research that we do costs a lot of money, depending on the project, right? And the Office of Navy Research, which is a branch of the Department of Defense, has been supporting me as a postdoctoral fellow for over 10 years now. And I did my research, my PhD research at Rutgers University in neuroscience and physiology, and then I went on to do a postdoctoral fellowship funded by the Office of Navy Research to understand the cellular and molecular mechanisms of high pressure oxygen as it pertains to oxygen toxicity, which is a limitation for Navy SEAL divers and hyperbaric oxygen therapy, which I'll talk a little bit about. And we have a number of industry partners, including Epigenics Foundation, Scivation, Quest Nutrition. You guys may be familiar with the Quest bars, the protein bars. They are actually, steering their research into developing food products to support nutritional ketosis. And it's been fun working with them to do that. And we're also funded by a variety of small foundations that support the development of therapies for particular metabolic diseases or neurological disorders. And our company, in full disclaimer, I started a company about 2 months ago called Ketone Technologies, and the purpose of this company is to partner with agencies like NASA, Special Operations Forces, to fund research to further develop and test technologies to enhance warfighter safety, performance, and resilience in extreme environments. And some of the presentation my university tells me to say, some of the information I'll be giving you today on various technologies are patented by the University of South Florida. And some of these patents are licensed to companies that are developing ketone products that you can drink the product and it puts you into nutritional ketosis, similar in many ways to the benefits you get from the ketogenic diet that's used clinically for a growing number of therapeutic applications. And of course, the information contained in this presentation is not meant to be taken as medical advice. I'm a PhD. I do partner with clinicians. I'm just coming from a conference right now, meeting with a neurology director, and we're going to use some of the technologies that I'm talking about today in a clinical trial at Tampa General Hospital. Hopefully, we're writing a grant for that. So our research fundamentally is really about developing an understanding for human physiology and neuroscience, I would say, to enhance an understanding how we can thrive in these extreme environments to enhance safety, performance, and resilience in these extreme environments, which includes the space environment, the undersea environment, and NASA actually does a lot of their analog missions. For example, an Earth-based space analog for the Mars mission would be the NASA Extreme Environment Mission Operations called NEMO 21. This is a picture of NEMO 21. And I will be a crew member on NEMO 22. And Saturday, I leave to go down the Keys and do some training and be down underwater as an aquanaut for 10 days. And we'll be studying a variety of things on NEMO 22 that I'll be talking about today. And I think we'll be able to do a similar study, if you will, here and be recruiting volunteers. So I want you guys to pay attention and think about if this is something that you'd want to do, to actually be in nutritional ketosis to assess overall biomarkers for wellness, body composition, and cardio metabolic parameters and things like that. So the main focus of my research over the last few years has been understanding oxygen toxicity seizures, which is a limitation for hyperbaric oxygen therapy, which is used for a growing number of applications. There's 15 FDA-approved applications, including things like decompression sickness, if you're diving, carbon monoxide poisoning, enhancement of wounds. We are interested in looking at the application of hyperbaric oxygen therapy for traumatic brain injury, for a growing number of off-label applications too. So oxygen toxicity seizures, oxygen's a stimulant, and at high concentrations, it can cause a seizure. And when the Special Operations Forces guys and the Navy SEALs use a closed-circuit rebreather apparatus, like the Draeger rebreather, it's a unique device, it's compact, and it essentially involves breathing 100% oxygen in a closed circuit to, there's a stealth component to this, so there's no bubbles coming out as you are diving underwater, and that's the advantage. You can sneak up on people and they can't see the bubbles coming across the water. The disadvantage is that breathing high oxygen at pressure, the deeper you go, the higher the pressure, the more potential you have for oxygen toxicity. And at just 50 feet of seawater or more, the potential for CNS oxygen toxicity exists within 10 minutes. So it's about 50 feet of seawater is about 2.5 atmospheres of oxygen if you're breathing 100% oxygen. So there is currently no way to detect whether you're going to have a seizure underwater, and there is no way to mitigate oxygen toxicity seizures. So to understand this, we've developed a variety of technologies. I actually had a video in here. I don't have the video to open for you today, but it shows someone undergoing oxygen toxicity seizures. What the military does or used to do is basically test the threshold of divers for CNS oxygen toxicity. And I always thought this is really hard to get past IRB. They're basically putting them on 2.5 to 3 atmospheres of oxygen and kind of pushing the limits. It's equivalent to about 55 feet of seawater. And in this case, this was a video of a guy. He's in a hyperbaric chamber. The guy on sitting here is breathing air. So the chamber is pressurized with hyperbaric air, but he's breathing 100% oxygen with a mask. And he goes into a very violent tonic-clonic seizure. And I presented this to one crowd, and it like freaked everybody out. And people were leaving the room, so I don't show the video anymore. But it's a dramatic demonstration of what high oxygen can do to your brain. It's increasing oxidative stress in the brain, the free radicals that we talk about in the brain, and it also it involves a breakdown of fundamentally brain energy metabolism. And there comes in the key piece where nutritional ketosis, which these ketone molecules that we study, can help to preserve brain energy metabolism in the face of an oxidative challenge, which would be high pressure oxygen. So anyway, he has a seizure, and the guy that's monitoring him in the chair, as soon as he starts having a grand mal seizure, was able to rip off the mask, and he goes from breathing 100% oxygen to air, which is 20% oxygen, and he quickly stops having a seizure. So there are ways now to detect an impending seizure. And we are working with Duke University. We have a study that's under IRB review right now that will involve giving the ketogenic diet and ketone supplementation to people in this scenario, although they will be underwater up to a certain extent because your physiology changes when you get underwater to some extent, and essentially pushing them almost to seizure and looking at the latency to the detection of certain impending physiological biomarkers that could develop a seizure. So we're actually moving our rat studies that I'm talking about into human studies into this kind of scenario.
So Dr. D, just
Yes.
to get everybody oriented, because you've got a lot of acquirers here, they don't even understand the concept of where an IRB is in the site.
Oh, sure. Okay.
What an IRB even is.
Yeah, thanks for bringing that up. And if there's anything that in my presentation that's not clear, feel free to stop me. I have enough time to field some questions. I heard you guys are an inquisitive bunch, so I can field questions as we go along, and I will continue. I have some slides that are heavy in the science, but it's fairly easy to break it down into layman's terms. So an institutional review board, an IRB, is an ethics committee that determines whether the research that you're doing is one, scientifically sound, has scientific merit behind it, and is up to the standards to where human welfare is accounted for within the IRB protocol. So we don't want to harm the individual. There are various consent forms that the individuals have to sign. Each institution is different. My student here, Andrew Kutnick, and I and our lab team just went through an IRB process through NASA, which they are very risk averse. So they did not allow a lot of things that would typically be passed. So it's an ethics review board. And so this type of research right now can be perceived as ethically, is unethical. And so you have to design the study in a way, for example, Duke University is designing it to test physiological biomarkers or neurological biomarkers that would detect an incoming seizure before it actually happens. So instead of doing something like this where you're pushing the guys to seizure, to vet out the guys that may be susceptible out in the field.
What's the long-term effect of the
So inducing a seizure with oxygen toxicity is quickly reversible as soon as you remove the 100% oxygen. But in patients that have seizures, I will say seizures beget seizures, right? So the more seizures you have, the more susceptible you are to having seizures. But the etiology or the cause of epilepsy is largely unknown in most cases. So it'll really determine what the cause of that seizure is. It could be a penetrating traumatic brain injury from an IED explosive causes seizures in about 85% of guys that get a brain injury. When they go back home, 85% of them will have seizures. If it's just a concussion, maybe only about 10%. So in that case, brain injury, you have temporal lobe epilepsy, there's malformations in the brain, there's various genetic disorders like from this experiment, it's not known, the seizure itself is not, because it's usually happens very infrequently, but it's not thought that it's contributed, like people who have seizures in this scenario will not have a seizure in everyday life. That has never happened. And we do a number of seizures on rats and animal models and have not seen that it induces seizures outside of that extreme environment. But it's a good question. And we want to kind of study when a seizure happens, it activates a neural network that we think that if a certain amount of time goes on, it'll probably dissipate. But if it happens, if the stress happens again within a certain time frame, it can make that seizure more likely to happen again, I guess you could say. So we use a variety of methods in our lab, including various forms of microscopy, fluorescence microscopy, confocal electrophysiology. All these techniques allow us to understand fundamentally why these seizures are happening. And we can't develop a mitigation strategy or understand the problem unless we develop technologies that allow us to study the problem. So we've taken some of these kind of like off-the-shelf technologies and we've installed them inside of a hyperbaric chamber. And for example, putting a microscope inside of a hyperbaric chamber so we can look at the cells and even down to the membrane and the mitochondria to understand fundamentally what's happening at the cellular level. So we have, these technologies can look at free radical production in real time. It can look at kind of the viscoelasticity of the membrane, like really high level kind of information mechanistically as to what's going on. And we do studies where we can look at individual cells all the way up to whole animal studies where we measure physiological effects like EEG, heart rate, we look at respiration rate, and we can detect with the various sensors that we put in the animal when the seizure occurred, and we also have a video camera to detect the seizure. And the seizure is quickly reversible. As soon as the seizure happens within our experiment, we can flip a switch and flush in air instead of 100% oxygen, and it stops the seizure. So that's one of the benefits to the seizure model that we study. So in studying this from a cell to a tissue to a whole animal model, we've demonstrated essentially that oxygen causes the development of these free radical molecules. And It also contributes to neuroinflammation and hyperexcitability of the brain. So oxygen's a stimulant, which is good up to a certain extent, but too much oxygen in the brain causes aberrant or dysregulation in brain activity, which contributes to the seizure. And these oxygen toxicity seizures are largely resistant to drug therapy. So, so then comes the problem, that you don't want to load up a warfighter going into battle using a closed circuit rebreather with high doses of anti-epileptic drugs, because it impairs physical performance and also cognitive performance. So a number of strategies have been tested to delay or mitigate oxygen toxicity seizures. And I studied these as a resident, as a postdoctoral fellow and resident. We looked at various antioxidant cocktails, and they largely failed. Anti-epileptic drugs at therapeutic doses used for epilepsy fail, but in really high doses to the point where they're sedating or almost putting you comatose can delay the seizure, but they're not very useful in a mission operation situation. It was observed from the literature in various animal models that fasting ketosis could delay the latency to seizure up to 200%. So I got locked on as to why does fasting, and for a human it would be like 24 to 36 hours, why does that protect the brain from seizures? I became fascinated in understanding that. And in 1967, there was a study done at Harvard Medical School that showed that if you fasted subjects, in this case, it was pretty extreme, up to 40 days, the brain has this metabolic flexibility from using glucose, using sugar as its energy source, to using ketone bodies, which are breakdown products of fats, right? And after about, in a fed state, if you're eating carbohydrates in your diet, about 100% of the energy that your brain is getting is coming from glucose. If you fasted or if you're on a ketogenic diet, I'll talk about later, about almost 60 to 70% of brain energy metabolism is being replaced by metabolism of these ketone molecules. So it was thought prior to this, that prior to the study in 1967, that the brain could only use glucose as an energy source. So this essentially rewrote the textbooks in our understanding of brain energy metabolism. So after about a week or so, after about 10 days, the level of ketones in the blood actually exceed that of the level of glucose. So there's free flow of ketones across the blood-brain barrier to energize the brain. So the only way to get your ketones elevated is for prolonged fasting or starvation, or to use a very restrictive ketogenic diet that I'll talk about. So,
Question?
Yeah, sure.
Do you know if the brain uses glucose first completely, then switches to the ketones, or does it go back and forth?
Yeah, that's a good question. I get that question a lot. And I think what's going on, there's some studies being done using what's called a dual PET scan, where you look at glucose and ketone metabolism at the same time. The answer is that your brain will kind of use whatever is available. So if you have 3 millimolar of concentration of ketones and 3 millimolar of glucose in the brain, they're burning them and pulling them from the blood at the same rate in a healthy individual. But if you were to get traumatic brain injury, if you have Alzheimer's disease, if you have a number of neurological disorders, the pathways that allow the brain to use glucose for energy are impaired. And that could be the glucose transporter, like the GLUT3 transporter, or an enzyme called pyruvate dehydrogenase. And impairment of these pathways would preferentially shuttle ketones to the brain for energy in many pathological situations or brain injury situations. So this is very important as we talk about the therapeutic applications of ketones.
Can I piggyback on that real quick?
Yeah.
So on the TBI side, most of the time they're using the FDG PETs. So what are they, because you mentioned also doing that for ketones, how are they measuring the ketone metabolism?
They use a radio-labeled ketone molecule.
Is that clinically now are they doing that, or is that just still research?
Yeah, they're using, Stephen Cooney is using it, and there's a number of clinics now that are doing studies using, it's a radio-labeled acetoacetate. So there's two ketone bodies, beta-hydroxybutyrate and acetoacetate. But yes, you're right. So fluorodeoxyglucose, FDG, is used.
So you might not be getting somebody who might be in ketosis when they're looking at it and they're trying to figure it out because all they're doing is FDG.
Yes,
Okay.
yes, so they would have to do so classically what you see with someone with Alzheimer's disease, if you do an FDG PET scan, it's considerably dimmer. The intensity of the scan is much less than a normal healthy subject. So you see that with Alzheimer's disease, and that's indicative of impaired glucose utilization in the brain, right? So traumatic brain injury can cause the same thing, impairment of glucose utilization, and it's almost like Alzheimer's disease in real time. So it takes years, decades to progressively decrease brain energy metabolism in an Alzheimer's patient, but someone with traumatic brain injury, the best indication of that person's ability to recover will be what that FDG PET scan says. And the dimmer the PET scan, the more likely that patient is going to have a seizure, and it's more potential, I think, that ketones could be therapeutic. So nutritional ketosis mimics fasting ketosis in many ways, and it has, most importantly, from a clinical perspective, it has the anticonvulsant, anti-seizure properties of fasting. So fasting has been used for millennia. I mean, it's in the Bible. Hippocrates talked about it in 400 BC, and it was used in the late 1800s and early 1900s until the ketogenic diet was developed in the early 1920s. And the ketogenic diet mimics fasting by preferentially shuttling fat oxidation into the liver, and fat oxidation in the liver contributes to the production of these ketone bodies, beta-hydroxybutyrate and acetoacetate. For this to happen, for accelerated beta oxidation of fat to occur in the liver, you have to some extent, decrease glycogen levels in the liver and also suppress the hormone insulin. If we're not eating carbohydrates, if we're not eating large amounts of protein, our insulin levels stay very low. And low insulin means that you're oxidizing or burning a lot of fat, right? So the diet tends to put us in a metabolic state where the hormone insulin is suppressed, and that mobilizes fat from our bodies and helps burn the fat that we're eating. And the more fat that we burn in our liver, the more ketone bodies that we produce. And these ketone bodies are beta-hydroxybutyrate, acetoacetate, and acetone. And these two molecules, acetoacetate and beta-hydroxybutyrate, they contain a lot of energy in their molecules, so they have the capacity to generate lots of ATP. That's the cell's energetic currency in the brain and in the heart and even in the skeletal muscle. So we've known for years that the heart can function more efficiently off ketones than it does off glucose. So there may be implications for a ketogenic therapy for the heart. And then I talked about the brain being able to use ketones. And we know that skeletal muscle and even skin can use ketones. So before I go any further, I always like to clarify some ketone terminology. I think it's good because ketones have gotten a bad rap over the years. We clinicians, many of the students that I teach at the medical school, they only understand ketosis in the context of diabetic ketoacidosis. If they see ketones in the blood or in the urine, that's a bad thing. That's an indication that something is metabolically off and they are being poisoned by this energy metabolite. So let me talk a little bit about this. So ketone bodies are essentially energy substrates from fat oxidation. You're in a state of ketosis when beta-hydroxybutyrate, which is something that you can measure with a commercially available meter that's similar to a glucose meter, is above 0.5 millimolar. And there's a urine ketone strip that can also indicate your level of ketosis. So it's a dietary strategy. The ketogenic diet is a dietary strategy to elevate ketones. And there's different ways to do that, and I'll give an overview of the different ways to do that. Ketoacidosis is what most people you talk to about ketosis are most concerned with. And it's very specifically kind of a situation that occurs only in type 1 diabetics. So it's a pathologically high level of ketones, which is up 10 millimolar or higher, and it results exclusively from insulin insufficiency. So it is not something, nutritional ketosis is far different than diabetic ketoacidosis. So that's a really important point I want to make before I go any further. And keto adaptation is a time-dependent physiological shift of your body going from a carbohydrate-based metabolism to a fat and ketone metabolism. And there's a lot of therapeutic benefits to that and some performance benefits and enhancement of resilience that I'll talk about. And something new that's been kind of put on the radar of science and even in the public is the use of exogenous ketones. So we know that ketones are a source of energy. Exogenous ketones produced synthetically or naturally through natural processes can represent something that we can consume that can give our body energy. It's much like actually creatine monohydrate, which a lot of you guys have probably heard about. You know, it's used in sports. It's one of the most popular supplements in sports. When you consume it, it helps your body generate energy, ATP, and ketones do the same thing, but in a little bit of a different way. So they are just essentially energy molecules. And these are two people who actually got me directed into this research. Dr. John Monroe, he treats children at University of Calgary. He's the chair of neurology up there, and he was the first person I contacted to ask if he thought nutritional ketosis could mitigate oxygen toxicity seizures, and he thought it could ameliorate it. And that inspired me to look into the science, much of the science that he did. He spearheaded a lot of the ketone research. And then I got more into how do I implement this clinically and who's doing it and what kind of results are they getting and what kind of seizure types. You know, are they treating grand mal seizures? So I contacted Johns Hopkins. Eric Kossoff was kind enough to talk to me about the vast range of experience he had treating children and also treating adults with the ketogenic diet and with the modified Atkins diet or modified ketogenic diet. And that's kind of the diet that I'm going to be talking about. The modified ketogenic diet is much more liberal in protein, and it's actually a pretty easy diet to follow. I've been following it for about 8 years now, and he's had really good success with the modified ketogenic diet, almost as good as a very restrictive classical ketogenic diet. So I'll give examples of that as I move along. And one of the people that I connected with early on was Mike Dancer, who used the modified ketogenic diet. So instead of 10% protein, it's like 20 or 30% protein. The carbohydrates are about 5% or less, with the balance of the energy coming from fat. So Mike connected with me early on, and he was going to have, he had what the doctor called terminal epilepsy, and he tried every anticonvulsant drug in combinations, and he was really into fitness and working out too, and I suggested that he try the ketogenic diet, and it worked remarkably well. He became like kind of like the poster child for the adults to use the ketogenic diet, and he's been like a spokesperson for the foundation, Matthew's Friends, which is, there's an equivalent foundation here in the United States called the Charlie Foundation, and I've gotten to know Mike very well. We have traveled around the world actually talking about the ketogenic diet and the anti-seizure effects. Mike is unable to drive a car because of his epilepsy. But on the ketogenic diet, we've had a lot of experiences together where we've been up in the air in an airplane, and he's piloted an airplane over the hills of Italy, and we've had some great experiences together. And he continues, after 9 years, he continues to use the ketogenic diet to manage his quote-unquote terminal epilepsy. And there are a growing number of applications, and that's kind of the theme of my talk today, is that when I got into this in 2007 and 8, the only application was pediatric epilepsy, and now there's an exploding number of publications on PubMed to just demonstrate that nutrition is a very powerful metabolic therapy, and one of the most powerful diets is the ketogenic diet, because it dramatically changes your metabolic physiology in ways that can be therapeutic and potentially performance enhancing. So I'm going to touch on some of these as we move forward. So our lab has developed forms of ketones that can be taken orally that can put your body into a state of starvation or therapeutic level ketosis within, if you look at the time frame, within 30 to 60 minutes, we can be into ketosis. And it was sort of this technology that the Department of Defense was interested in funding, the Office of Navy Research in particular, and we studied the effects of these ketone molecules that we can synthesize in the lab and test in our experiments. And we test them primarily in rodent models, but now we're moving to more human studies. And the human equivalent would be about 1 gram per kilogram per day. And that could be in 2 or 3 doses. So think of like the 5-hour energy drinks that they sell, about that equivalent of ketones. It was something that tastes really bad, almost like diesel or gasoline or something. So we're working on the taste of these things. So the taste is like.
Is that what you gave me in the office? I got a little package of diesel.
No, they have been, they're formulas that are not quite as potent. They're almost about half as potent, far more potent than like an MCT oil. But yeah, they're flavored to where they actually taste fairly good. But the ketone ester in its pure form, the most potent form, potency is like inversely proportional to taste. So the more potent it is, the worse it's going to taste. But these things, if I was to consume, about half of that, it would put me, if I consumed it and you looked at my blood, it would look like I fasted for a week. Like my physiology would change to that. And there's various tools that we use. The glucose ketone meter, it measures both glucose and ketone. Abbott Labs makes it. And depending on what strip you stick in it, you can measure glucose is 70 milligrams per deciliter and 5.9 millimolar. And that is something equivalent to, these are numbers that you'd see in people that have fasted for 7 to 10 days. And you can achieve that within an hour. And there's a breath ketone meter that I've tested, and also a urine ketone strip. And these are all things that we utilize in the lab to test the various ketogenic diets and ketone supplements. So, yeah. Sure.
So are you testing it only in the form of the ketones in the blood and breath, or have you been able to test it on someone that you're inducing the seizures and actually seeing the results of this liquid ketosis, induced ketosis? My question is it proving to be effective in reducing the seizure, or simply resulting in your blood as showing you in ketosis?
So good question. Because it's not completely clear. Well, now people are studying it and starting to get some publications. The Johns Hopkins group studies the diet, and there are people that study the diet feel like the ketone levels tightly correlate with the seizure control they see in kids. And other investigators will use like a low carb, low glycemic index diet and still get benefits, anti-seizure benefits, but there's no ketones that are being registered in the blood, which is really interesting. So what we did in our studies was actually we had the rats eat the standard high carbohydrate diet, and then we gave ketones at different levels. Now we're doing like graded levels of ketones until we found a level that induces the ketosis high enough that confers an anti-seizure, anti-epilepsy effect in our model system. So it's a good question, and I think as we move along, it's going to be really important to correlate what dosage and what level of ketones is needed to produce an anti-seizure, anti-epilepsy effect in different types of epilepsies. And we do it in animal models, so different types of animal models.
So this is back to the understanding of the IRB. So they're not going to do it in a human, which is what she was asking.
Yeah.
They're not at that
So
stage.
doing it now. Well, we're working with Duke University, and they will be testing student athletes that are surrogates for like the military personnel, and the goal for that study for the IRB is to have a study and working with a registered dietitian to get their ketone levels above 0.5 to 1, and then they come in with a ketone supplement that things are commercially available that can get them above 1 millimolar into the 2 millimolar range. And that has been shown sort of to correlate with metabolic management of seizures. So there's a lot that we don't know, but for humans, it's thought that it's really important to register ketones on the urine stick to actually get efficacy of the diet for anti-seizure effects. But the exact levels are not known because it's kind of expensive to measure your blood ketones all the time, and not everybody does it when they're at home, and a lot of kids don't like to get their finger pricked and things like that. So we need to develop technologies that can better assess our ketone levels and then do the studies to correlate it to anti-seizure effect. Think you have another?
Is your oral ketone considered nutraceutical, regulated by, say, the FDA in a sense? Is it say, pharmaceutical nutraceutical, or not yet determined?
Yeah, that's a good question. Some of them are, and some of them aren't, depending upon the molecule. A ketone salt is a mineral or like a sodium, potassium, calcium, or magnesium bound ionically to a ketone, beta-hydroxybutyrate, whereas a ketone ester, and those are things that are found in an animal that's in ketosis, will have sodium and these minerals and beta-hydroxybutyrate, and so that's kind of found in nature, whereas a ketone ester has an ester bond that's not found in nature. So it becomes kind of a fuzzy, but when you ingest it, we have the enzymes that break it apart, and then it's bioidentical form. So the FDA, there's a little bit of a fuzzy, so they consider it something that should have to go through a regulatory pathway that would be called GRAS, which means Generally Recognized as Safe, GRAS. And to get a substance GRAS approved, you have to submit an application to the FDA, and it needs to, you have to show pharmacokinetic data, toxicity data, and some data in humans, typically. So that's what we're going through now for the more potent versions.
Last one on your meter you're using for habit, have you found that it was accurate we've looked at them before from our sports dietitians looking at it, and it was mostly the accuracy concerned a non-diseased population, so someone who doesn't have diabetes, in a sense, and the accuracy may not be as good. And so some of the things we've looked at, I don't know if you've had any experience with the ones you're using.
Yeah, we have a bunch of meters. So one time, to answer this question, I set up 5 meters and took an amount of blood and put that blood on all the meters, on all the strips, and it was within like 0.3. It was like, the level of ketones was like 3 millimolar, and the range from the 5 meters was like 2.7 to like 3.3. So, and I've been working with kind of the engineers behind it, and they said, yeah, like plus or minus like 10%, and that's about what we see. So it's not as accurate as like a gas mass spec or gas chromatography kind of GCMS setup. We did a study where we measured using the meter, and then we sent the blood to Case Western, where they used the serum there, and it was a fairly tight correlation with it. I mean, it was much more precise with other lab techniques, but it's a good, it's the gold standard for kind of the do-it-yourself ketone measurement.
Thank you.
Yeah.
With regard to human performance, do the therapeutic ketones reduce or eliminate any side effects that you have when you do the slow phasing in of the nutritional ketosis diet?
Yeah, so I talked about your brain kind of running off glucose as its primary energy source. And when you get on the ketogenic diet, your brain has that metabolic flexibility to adapt to using ketones as an energy source, but your brain also goes through like glucose withdrawal and will desire that fuel until it adapts to using ketones as an energy source. And there's kind of an upregulation of the transporter. There's an upregulation of the enzymes that make ketones. So you might be low at first, and then it comes up. And then there's an upregulation of the ketolytic enzymes that actually generate the energy from the ketones in the cells. So there's a number of things responsible for the adaptations. And some of the investigators that I'm in contact with have studied this over the years and show that after about 2 to 3 weeks, there may be a 50% increase in the protein levels for the transporter. So we do have adaptations. The more you do the ketogenic diet, the easier it gets, and the more benefits you'll derive from it. And that's probably due to this keto adaptation that's known. So, let's see if I can advance this. Oh, there we So as our studies evolved, we did the seizure studies and the rodent models and showed almost a 600% increase in delay to seizure and seizure protection. So what that amounted to is that at 5 atmospheres of oxygen typically produces a seizure in 10 minutes. And if you're in a state of ketosis with a ketone supplement, you could push that out to 1 hour. And 5 atmospheres of oxygen is really high. If you're using a closed circuit rebreather, that's like going down to 132 feet of seawater. Typically doesn't happen in a special ops mission. So that's, you'd have a seizure within 5 to 10 minutes. So giving you an hour of time is a pretty significant effect. So now we're studying these effects of these ketone molecules, a ketone ester, and other formulations in different animal models of seizures. And now we're also interested in other potential applications for special operations and also for NASA, enhancing performance, potentially radiation protection. There's some work by a colleague of mine at Barrow Neurological Institute. She demonstrated in a mouse model, a brain tumor model, that the ketones sensitize the cancer cells to being killed by radiation, and the ketones protect the normal healthy cells. And she's published that, and that actually inspired a clinical trial from her animal studies, a clinical trial that at her institute that she was part of. And another area that is very hot right now is the effects of ketones on cognitive performance. So our lab right now is studying a variety of things. I talked about CNS oxygen toxicity seizures. We look at neurological disorders, rare genetic disorders like the glucose transporter deficiency. Some kids lack a transporter to get glucose across the blood-brain barrier. And for these kids, the ketogenic diet is the only standard of care offered for these kids as therapy. So the diets are hard to follow. So a ketone supplement, which would elevate ketones and give, confer protection or give that energy source to these kids in place of glucose, is an important therapeutic thing to look into. So a big part of our research right now is looking at the effects of ketone supplementation on a mouse model. And I will be next month at this time, I'll be presenting to the Glucose Deficiency One Foundation to talk about the latest research that we're doing, and also talk to the clinicians that are just starting to use ketone supplements in combination with the ketogenic diet in their patients. And many of them are doing it in kind of an informal, non-IRB approved study, but getting great results from it. So anxiety behavior, about 2 months ago, we published a paper showing that ketones reduce anxiety in an animal model. So we're following up on that. Motor function, we're doing a lot of pharmacokinetic studies to understand fundamentally what types of ketone molecules and what formulations how fast can they elevate ketones in the blood, and how long can it sustain it. So different types of ketones have different effects, and we're teasing all that out now. We have shown that ketones lower blood glucose, and that I think is really important for some work that we want to do perhaps in type 2 diabetics and people who have metabolic syndrome. It could be an important way to regulate glycemia. A big area of our research is actually looking at cancer. About 50% of more of the research that we do is focused on cancer. Part of that is mitigating the muscle loss associated with cancer, called cancer cachexia. My student here today, Andrew Kutnick, his PhD dissertation work is actually looking, defining an animal model of cancer cachexia and to further develop a mitigation strategy to prevent or mitigate the muscle loss and wasting associated with cancer. One of my prior students looked at wound healing. So she demonstrated that elevating ketones in the blood can enhance blood flow to an ischemic wound and enhance the wound healing process, especially in an older and aged model. As we get further along and mechanistically define what's going on, inflammation is a big topic. And the root cause of many diseases is chronic inflammation. And we're finding that that ketones are more than a metabolite, that they have important signaling properties, including the suppression of inflammatory pathways that are associated with age-related chronic diseases. And we've published on this, and a lot of people are scrambling to get into the space to understand how ketones suppress inflammation. And another hot topic is ketones and longevity. So there was a paper, a review by Dr. Veach's group. Dr. Veach is at the NIH, and he was a student of Hans Krebs, of the Krebs cycle. If you guys had biology, you remember the Krebs cycle. So Dr. Veach was actually kind of a mentor to me to get into this field, and is of the opinion that ketones can enhance longevity and potentially extend lifespan or health span in humans, and is kind of championing to get those studies done. And enhancement of metabolic efficiency is something that we want to look at. It's kind of difficult to study. I actually touched on it a little bit with my friend Peter Attia. He's a medical doctor, and we designed a study in his, it was literally done in his garage, or his friend's garage, where we induced acute ketosis, and we monitored oxygen consumption with a fixed power output. So we had him pedal 180 watts on a bike in the absence and the presence of being in ketosis. And we demonstrated that the oxygen consumption reduced about 6 to 8%, almost 9%, when his body was being fueled off ketones. So from a performance standpoint, from a metabolic efficiency standpoint, this could be pretty significant, but no one has actually kind of done a controlled study yet. So we're interested in kind of following up on this and doing kind of an approved study at an institute. If any of you folks out there are interested in doing research or know of anyone that's interested in doing this kind of research, you can let me know. And so there has been a number of studies that have been done, including one by Cox et al., which showed that nutritional ketosis can alter the fuel preference and thereby the endurance performance of elite athletes, and these are cyclists. And some of the findings that they demonstrated was that ketosis shifts your metabolic physiology from oxidizing or from utilizing glycolysis to utilizing more fat oxidation in the muscle for fuel. That when you consume exogenous ketones in the form of a ketone ester, that it preserves muscle glycogen. We know that when we're running a race, especially an endurance race, our bonking, our physical activity sharply declines with the depletion of muscle glycogen. So there was an interesting enhancement or preservation of muscle glycogen, and one of the most impressive results that they had was a 50% reduction in lactate levels. So that's the burn that we experience when we're exercising, and the factors that are influenced by lactate accumulation can impair muscle performance. So a reduction in lactate has gotten a lot of attention in the sports world, and ketones are probably doing that because you're preferentially burning more fat and ketones. So lactate comes from the metabolism of glucose, right? So if you're burning less glucose, you get less lactate, less burn. So that can have significant performance applications. And we wrote a review, Brendan Egan and I wrote a review on this topic. It was published in Cell Metabolism, that we think that ketone-induced reduction in perceived exertion is greater when you're in a state of ketosis, because your brain's essentially happy. It's getting this fuel source. It's not responding to a lack of glucose because the ketones are more kind of consistent in the blood. And if your ketones are elevated, your central nervous system and your neurons are firing more efficiently. And it's the firing of these neurons in your central nervous system that contract the muscle, right? So if you have better fuel flow to your central nervous system, you can have better motor performance. So this needs to be studied, but it's just a hypothesis that we had that we talked about in this review article here. So what are the mechanisms? I'm not going to get into this, and in other of my academic talks, I might have 30 or 40 slides to talk about all these mechanisms here. I highlighted some of them in red. These are things that we're actively studying or interested in studying right now, but I'll just say it's not just one mechanism. So when you use creatine monohydrate, we know that the energy reserves increase, like the phosphocreatine to creatine ratio will go up, and that'll make more ATP. But with nutritional ketosis, there are so many things going on. It's many things working together in synergy to produce an output. And the output could be the neuroprotective anticonvulsant effect, or the suppression of inflammation, or the enhancement of motor function or athletic performance. So the point is that it's difficult to study because there's many different things going on at once. I have given talks to pharmaceutical companies where they are interested in the diet because it works better than their drug. So I will present there, and they want one mechanism because they can reverse engineer kind of a drug, and then I throw this slide up and they get kind of frustrated. It's like, well, how are we supposed to develop a drug that does all this? And that's kind of the beauty of metabolism and the beauty of a metabolic therapy, a dietary therapy, is that it works through many different mechanisms kind of in synergy. So the implementation of the ketogenic diet, let me see how much time I have left here. So I can get through this pretty quick and then leave some time for questions too. So there are different strategies to induce nutritional ketosis. So there's a variety of different ketogenic diets defined by the macronutrient ratio. So the ratio of fats to protein to carbohydrates, right? The classical ketogenic diet is actually like 90% fat and pretty low in protein relative to the Western diet. It's like 7% protein to 10% and just 3% carbohydrates. Like this diet was thought to, is really draconian. It's very difficult to follow. Whereas a modified Atkins diet has been shown in adult epilepsy patients to almost have the same level of efficacy. And it's much more liberal in the protein source, in the protein amounts that are allowed, up to 25%. And then you have the low glycemic index diet, and a version of the ketogenic diet that uses types of fat called medium chain triglycerides, which are derived from coconut oil. And this is a type of fat that when it's consumed, it more readily converts to ketones. So it's kind of interesting. If you're eating a normal carbohydrate-based diet and you consume coconut oil or these medium chain triglycerides in a pure form, which are found in coconut oil, you can elevate your ketone levels without even doing any kind of restriction. So think of them as like the poor person's ketone ester, right? The ketone ester shoots your ketone levels up really high, whereas ketogenic fats can actually give you a therapeutic effect without necessarily having to follow the diet. So I became interested in utilizing these types of fats and combining them in formulations that can kind of enhance the effect of different exogenous ketones. So you have, strategies could be any variation of these diets, and this is just the macronutrient ratio, and then you get into the whole other thing of what foods, should you choose for this. So the types of fats that make up the 90% or the 70% are really important, and that's something that we're really interested in studying. The ratio of omega-6 fat to omega-3 fats, the composition of monounsaturated fatty acids. You got fish oil like docosahexaenoic acid and how much should be in there. So we want to work on developing the optimized ketogenic diet with the optimal ratios and the optimal kind of selection of different types of fats. So you have a variety of diets you can pick and foods, and different types of ketone supplementation are coming online. And when you follow this, we still don't really know what's the optimal range of nutritional ketosis. So there are various measurement tools that I'll overview in the next slide, but it's just thought from talking to clinicians that are implementing this in patients, from upper level athletes, including Olympic athletes and cyclists and triathletes, and people that are just doing this to enhance their overall health and well-being, that the optimal ketogenic zone is somewhere between 1 to 3 millimolar. And you may not have to stay in this all the time to get the benefits. Maybe you could just do it a couple months out of a year. I personally find myself, I feel better if I'm in a state of nutritional ketosis, at least from a thinking point of view and a stable energy point of view. But I think it might be different for everybody, but there's different ways to achieve it. And there's different ways to assess your level of nutritional ketosis. From the cheap way to do it is with a keto stick that you can buy at any Walgreens or CVS. And they basically run about 10 to 25 cents per strip. And it basically tells you semi-quantitatively if you're in ketosis or not in ketosis. And it gives you, these are, the urine strips kind of get like a bad rap in that they're kind of a quick and dirty way to do it, but I find them to be fairly reliable, whereas the blood measurement is thought to be the gold standard, but blood measurements will fluctuate throughout the day. If I'm sitting at my desk and I'm on the ketogenic diet and I measure and I'm 3 millimolar and I have to go run around campus to do something or just do a brisk walk, I'm using that energy in form of ketones. My muscles are sucking it up, my brain's sucking it up. So my level may drop from 3 to 1.4, but my body's still producing ketones. So it's almost like a type 2 diabetic. When they exercise, their glucose comes down, right? Whereas the urine level is kind of a snapshot of what happens over a couple hours, you know, and I think it's almost like a better reflection of your overall. So there's a company working on a urine beta hydroxybutyrate measurement too. So there's a breath ketometer. You blow into it, and it goes from blue to green to yellow to red, right?
Is there a urine strip that already does the beta yet, or no? They're working on it?
Yeah, there was a company working on it, and they sent me some like beta testing models of it, but hasn't come online yet. But there are people also working. My student here wears a Dexcom-like device, so he has a continuous, Andrew has a continuous measurement of his blood glucose, and we frequently use him for experiments when we want to test things. We can turn his insulin off and then dose him up to see his glycemic response to things. So he becomes a great test subject for various things. But there are guys out there in Silicon Valley that are working on technologies that would allow for continuous ketone measurement, and they're also looking at glucose and lactate and other metabolites. The idea being that you put this Band-Aid-like device on you, and it goes to another device that can report to your cell phone, and at any given time, you can look at your ketone levels and say, I'm running a little bit low. You drink something, you get into that optimized zone that you know is optimal for you personally for cognitive and physical performance, or if you're a Navy SEAL, if you're going and you want to avert having a seizure, you can basically put yourself into that optimal zone. So think about having a pharmaceutical. We know the diet is more powerful than pharmaceuticals for epilepsy. Think about having a pharmaceutical where you can personalize, titrate the dose, and get into, you optimize that therapeutic zone. I mean, that's really important. So these technologies will probably come online within the next 3 to 5 years, I think. And I think they'll be very useful for people that are using the ketogenic diet, not only for therapeutic purposes, maybe for prevention of Alzheimer's disease or management of cancer even, which is a whole other topic I could go into, but for just personalized optimization of their body composition, of their, you know, their overall health and vitality and energy. So when it comes to medical applications, we've published a number of papers that describe getting into the metabolic zone, if you will. Let me see. So this actually evolved out of a figure from a study that was done on a glioblastoma patient, a patient that had cancer that was managing their cancer with a calorie-restricted ketogenic diet. And to get into the metabolic zone that we call it, we kind of need to bring our glucose down into the relatively low range. So a ketogenic diet that's calorie-restricted can achieve this, and also elevate our blood ketone levels essentially to a level that's at or above the levels of glucose. And once we achieve that level, kind of a colleague of mine and several others that are kind of do research in this space call that the metabolic zone, but it takes some time to achieve it. It can take up to a week for your body to get into a metabolic zone. But with the use of exogenous ketones, they have the ability to quickly lower blood glucose and elevate your ketones. So within 30 to 60 minutes, you could achieve the same metabolic zone. So this needs to be kind of validated with, beyond animal studies. We're interested in moving this type of application into human clinical trials.
What is the downside of getting that
Getting into
state
that
so fast?
very fast. You can run the risk of going into ketoacidosis if you have a very powerful ketogenic compound, but many of the things out there are such that if you consume them in quantities that would be toxic, you would kind of throw them up. There'd be such a high volume, they're kind of self-limiting, I guess you would say. So you couldn't really get blood levels up to a certain level. But I think of ketones, our body uses different forms of energy like carbohydrates and fats and protein, and ketones are just like another source of energy, another macronutrient. So they represent a source of energy. It's kind of like glucose. So if we consume too much of it, it can be converted to fat, and ketones they get excreted and then they can get converted into other things. But I think it will, you bring up an important question that these are kind of new molecules that are kind of developed and being utilized now. And we do need to do long-term animal work and also long-term human work before we're comfortable, at least with the levels here. But for many people, I think, if they have a terminal illness, I think it has a lot to offer them potentially, especially for managing seizures, which has kind of the greatest efficacy for that. So in summary, we know that ketones are a fuel, but they're also a signaling molecule, and the diet or starvation, calorie restriction can produce them, and they're a fuel for a variety of organs, especially the brain and the heart. And with exogenous ketones, can essentially circumvent the dietary restriction that's typically associated with getting into this therapeutic state. So it may not be optimal to completely not do the diet and do supplementation, but exogenous ketones may actually further augment the therapeutic efficacy of the diet or be an adjunct to the diet, to enhance the diet. So that's what we're interested in doing. And now when I get into this area of research, we only knew ketones as an alternative fuel for the brain, but now over the last decade, so much research has come online now to demonstrate all the potential signaling effects that ketones have. So this has gotten the pharmaceutical companies very interested in these ketone molecules and creating molecules that are similar to ketones or have the therapeutic effects. So it's been interesting to see their interest. So this kind of brings me to like my last slide or second to last slide, I think, which would be the current projects that we're working on now. One of them, and we're seeking collaborations, we're seeking to have volunteers for a similar study here locally, which would be kind of a more informal study. So the study that we have kind of ongoing now that is approved by the ethics committee, by the IRB, which would be a study with NASA. It's called the NASA Extreme Environment Mission Operations, or NEMO. This will be NEMO 22 mission. It'll be done at the Aquarius Habitat that's run by FIU down in the Keys. And another study we have going on kind of in parallel, it's an informal study, is with the Special Operations Forces Mountaineering Division. And they are not doing all the things here, but they are a group within the group that's doing the hike is taking ketone supplements, and we're testing a variety of measures, including probably the thing that we're doing most is a cognitive battery test, which involves a variety of things that we'll be measuring: blood ketones, blood glucose, urine ketones, all these different things we'll be measuring. So for the study that I envision that I could do here, some of the things I think would be most important would be nutrition tracking. For anyone that's interested in using nutritional ketosis as a tool for wellness, as a tool for weight loss, it's going to be very important to assess the efficacy of nutritional ketosis it's going to be very important to understand what you're already doing. So anyone that's interested in getting involved in this research, it'll be important to get at least 2 weeks of a dietary journal listing, simply writing down the types of foods that are being eaten and the amounts that are being eaten. And if you can, actually calculate the calories, that you're eating too, or maybe with that information, we could calculate the calories with various tools. So to get 2 weeks diet journal to figure out kind of what your normal diet is already composed of, and to, in addition to that, if that criteria can be met, 2 weeks, I think that's kind of good vetting out of who is kind of motivated to do this. We can do a fairly comprehensive body composition analysis. And my student, Andrew Kutnick here, could talk more about that if we have time later, but he's very skilled at looking at body composition using calipers, and we have an ultrasound device. And if it's available, maybe there's other techniques like a DEXA scanner that can be used if these kind of resources are available. And probably most importantly would be to me talking about ketosis would be actually to test and assess the level of ketosis that you have achieved if you do plan to implement this approach. And I talked about the urine ketone strips are probably the first thing you want to test, and that shows if you're in ketosis or not in ketosis. And these are things that are cheap. You can get at any Walgreens or CVS. And then from there, it'll be probably important to at least do once per week to do a blood ketone measurement at the same time each week at the same time of day. And that'll be an important measurement to correlate with the urine ketone measurements too. And these are things that can be bought on Amazon. We use them routinely in the lab, so we can help people seek these resources. And if you guys have any questions as I'm talking, feel free to interject. Yeah.
How expensive are ketones, exogenous to Induce? And then two, how long would your study be after the 2 week term? Like how long would you want to track a person? Because for someone who wants marathon season is starting, and that's going to totally mess with simultaneous effects. But
I would say a minimum of about 3 months, so 12 weeks would be optimal. I think we could actually get results with 8 weeks. I mean, we've done a study that we've published with 8 weeks. It was like a 2-week adaptation, so maybe you want to call it 10 weeks. I could have talked about it here, but it was for resistance training, looking at body composition, these things. So I would say ideally about 12 weeks, and maybe ideally like 6 months, if we could do it, if you could stick with it. But to really take, we talk about before and after measurements, I would say a bare minimum of 8 weeks, but ideally 12 weeks would be good. The other question was ketone supplementation cost. So to do nutritional ketosis, you don't have to take ketone supplementation, right? But I think it can help one get into a state of ketosis and maybe do it more comfortably, and you might get some benefits on top of it. But there are a number of books out there. The book that I like is The Art and Science of Low Carbohydrate Performance. It's by Jeff Volek. It's under $10 on Amazon, maybe like even $5 if you download the ebook, I think.
We're going to throw the link up.
Okay, great. So that's an important resource, and it becomes like almost a mandatory read for students entering my lab. So it's a great resource. So the cost of the ketone supplement varies depending upon the manufacturer. So you could go on Amazon and look. They range from anywhere from $1 per dose to some of the ones out there now are like $6 or $7 per dose. So I'd say on average maybe $1.50. About a cup of coffee is kind of like the average cost of the ketone supplements. And when they're consumed, they get your ketone levels up to what could be achieved typically with a clinical-based diet. And keep your ketones up for a couple hours, and then it comes back down, and you have to consume it again. I think we study them primarily for their therapeutic effects, but I think they may have real-world effects for the everyday person. And I think the jury's still out as to if they have effects for normal, healthy subjects. So these are still studies we want to do. Sleep, I think, is extremely underappreciated topic, and that is important for overall wellness and even body composition effects. We know that subjects that are chronically lacking sleep have metabolic syndrome. They have chronically elevated stress hormones and even C-reactive protein and inflammation. So sleep is really important. I have a lot of people contact me that when they get on the ketogenic diet or a low carbohydrate diet, their sleep improves dramatically. I've had a number of people with that have obstructive sleep apnea. So these people, they have kind of the excess weight can impair airway patency. So the genioglossus muscle in your tongue actually kind of falls back as you sleep, and having extra trunk weight or losing that trunk weight can improve obstructive sleep apnea. And when that improves, your blood pressure goes down, your glycemia improves, and so many other factors improve once your sleep is corrected. And we think that the ketogenic diet, I personally think that when you're in a state of ketosis that you require less sleep. So I know that I can function more efficiently off 5 or 6 hours of sleep, whereas before I started the ketogenic diet, I just couldn't function very effectively off 5 or 6 hours. So I feel like I can function better off less sleep. And with all the things that we have going on in the lab, we're like chronically sleep deprived many times. So sleep is something that we can look into, and Andrew, do you know if we will be able to get, in the months to come, if we'll be, my student Andrew here has kind of worked with various companies to get technologies that there may be a subset within this group that we can offer a ring that looks at things like heart rate variability and sleep timing and sleep architecture. So we get a snapshot of what kind of sleep you have. It just needs to be mated up with like a smartphone or a device. So these may be something that we can offer, they're pretty expensive devices, but the companies have worked with us to use this technology for the NASA mission, and after the NASA mission, we might be able to use it in this study. And also, if you're familiar with biking, you might know the Polar devices that you can wear that can give you a pretty good overall picture of heart rate and heart rate variability, which can give you some insight into your stress level. So your sympathetic system versus parasympathetic system. We may be able to use these devices too in the study. Gut microbiome is something that maybe we can look into. My wife is a cognitive behavioral neuroscientist, and she has some very kind of simple, easy to do questionnaires and apps that can assess things like reaction time, various cognitive tests that I think may improve after following the diet. And there's a variety of kind of off-the-shelf technologies that have been developed that look at saliva or a blood drop, where we can look at hormone analysis, things like thyroid, sex hormones, cardiometabolic measures. These are various kits that our lab purchases and uses. And another thing that we talked about was doing a genetic test. The 23andMe test will give you your DNA, and that information can be sent to various services that are online, including NutriTracker or Prometheus, which kind of tells you specifically and can personalize the type of diet that may be optimal for you. If you are deficient in some fatty acid oxidation enzyme, the ketogenic diet may not be for you. And there are, a number of people out there, who have deficiencies in various enzymes that may prevent them from making ketones or utilizing fatty acids for fuel. So that'll be important. So these are some of the tests, and ideally, we could do it all, but I think even if we do a third or half of this and recruit subjects for the study, you need a 2-week diet journal and recruit subjects for the study. We do body composition. We give you the tools to measure urine and blood ketosis and a variety of other things. I think that I know just from the feedback that I've gotten, I think will be we'll see some really impressive results on overall health biomarkers. And another thing that, you know, we can't do, but is just to go to your doctor, and typically most insurance plans offer like an annual blood screening where you get a comprehensive, what's called a CBC or CMP, a comprehensive metabolic panel that shows liver function, you know, liver enzyme, kidney function, and all these things. So it would be good to get that at the start and to go back to your doctor and after the diet, after the study, and then get that done again, and to assess the effects that are happening. So with that, I thank you for your time. I want to thank kind of all the people that have helped me. I can't do this work. I sit back and kind of, everybody else is kind of in the trenches doing the grunt work, and I just kind of oversee it all at this point. But our lab is a very dynamic lab. We're involved in a lot of different projects. Andrew, for example, is spearheading a whole project with the NASA NEMO mission, and is also managing his PhD dissertation work on a cancer study and looking at cancer muscle wasting, cancer cachexia. So we have a variety of folks in the lab. They all have an individual project, but we all have group projects where everybody pitches in. For example, the NASA project or some of the stuff we do with special operations forces to contribute. And we always want to thank our sponsors, because once again, I mean, we can't really do this work without sponsors helping us financially and providing the tools to get this done. And I like to always finish off with some resources, because a lot of people ask me, like, how can I get more information, the deep science or even the practical application. So a book that I contributed to with 2 chapters and also was an editor of is the Ketogenic Diet and Metabolic Therapies. It was a book published by Oxford Press, and it's basically very deep science, clinical and basic science of everything you want to know about the ketogenic diet, exercise performance, epilepsy, cancer, everything all in one book. It's kind of a pricey book, but I think you can get used copies for about half the price that a new copy is worth. Tripping Over the Truth, if you're interested in cancer, I wrote the foreword to this book, Tripping Over the Truth. It was written by a friend of mine, Travis Christofferson, and it kind of overlays the whole history of cancer and then talks about the metabolic theory of cancer, if you will. And many of the things that I talked about today, the ketogenic diet in particular is being used for a number of clinical trials right now as an adjuvant to cancer therapy. And I believe, our lab believes that the health of your mitochondria and your overall metabolic health will be an extremely important factor for preventing cancer. So if we can prevent cancer and kind of preserve the health of our mitochondria, we can prevent normal cells from transitioning into cancer cells. That's kind of what we believe. And I talked about these books and some of my mentors. And another book that I mentioned that was really important book was The Art and Science of Low Carbohydrate Performance. And I think by Dr. Jeff Volek, who's a PhD and also a registered dietitian, and has been doing this back before, you know, when I was in high school or before high school. So he's spent a lot of time and effort, and he runs a great lab at Ohio State University, which is looking at many different aspects of the ketogenic diet with a primary focus on athletic performance. And he's also doing some cancer studies now. And I have a website, ketonutrition.org, and on that website, if you click on resources, it can take you to a list of dietitians who can work one-on-one with you to develop the diet and to use it for clinical applications or even for performance applications. And the foundation that has inspired me to kind of get into this work was the Charlie Foundation, and that was Jim Abrams is the father of Charlie, and Jim Abrams is a Hollywood producer. He was the producer of the movie Airplane and a number of other movies. His son Charlie had drug-resistant epilepsy that did not respond to anything, and his personal research in the library, he stumbled across the ketogenic diet and was very angry that it was not offered to his son as a therapeutic approach after basically did a lot of damage using high doses of anti-epileptic drugs. And he took his son to Johns Hopkins. Long story short, his son responded remarkably well to the diet, and he was inspired to develop a foundation that promotes research and advocacy and awareness of the ketogenic diet for pediatric epilepsy and now for adult epilepsy. So I'd encourage you to, if you know someone with seizures or just interested in the ketogenic diet in general, to visit the charliefoundation.org. So with that, I think I'll stop talking, and it leaves a little bit of time for some questions. Yes, in the back.
You mentioned your 8-week resistance training study.
Yeah.
Focus on the results again.
Yeah, sure. Okay. So in that study was done at the University of Tampa, downtown, and it involved subjects who were resistant trained and fairly advanced, I would say, in regards to their strength performance, and they were adapted to the diet. They were given a 2-week adaptation to the diet, and they measured urine ketones and also blood ketones, and those who did not get into ketosis were not really eligible for the trial, because you can't cheat on the diet because it'll show up, as lack of ketones, unless you have some kind of pre-existing genetic factor that prevents you from getting into ketosis. So these subjects there was a group that followed the Western diet and basically continued to follow their normal diet, which was higher in carbohydrates. And the ketogenic diet that we utilized was the modified ketogenic diet or modified Atkins diet. So the overall results demonstrated that if you follow the ketogenic diet for that time frame, 8 weeks, and you subject the participants to an intense resistance training protocol, and you look at everything from hormones to body composition to strength, it was demonstrated that you can gain strength and gain muscle on a ketogenic diet, at least the modified ketogenic diet that's from 10% protein to 20 to 30% protein. And the main result, I guess, of interest in comparison to the Western diet was that the level of muscle that was accrued was similar, but they lost about double the amount of fat that the Western diet group lost. And I think that was the most, and that's what I see like anecdotally, that guys, even advanced guys, can continue to maintain their strength performance and their muscle, and they have favorable body composition alterations over time relative to them following a Western diet. So, but no remarkable effects in regards to like they didn't gain more strength, they didn't gain more muscle, but they were able to keep their strength and even gain some strength and muscle on a ketogenic diet, which was always a question, right? I was on a study prior to that that was done in Italy, and the group contacted me in Italy, and they were doing the study in gymnasts, and the gymnasts were doing a variety of things like dips and chin-ups and just kind of like almost like a CrossFit sort of workout, but what gymnasts do. And they found that they didn't gain muscle, but they were able to preserve their muscle as they were losing weight and had significant body composition alterations, or at least a loss in fat, and they were able to preserve that strength and muscle with a ketogenic diet. So that was like the first study I was involved in, and the second study that's out now, you can look it up, it's on PubMed, demonstrated that when a higher amount of protein was consumed and the intense training was documented and enforced, I guess you could say, that you can gain strength and muscle. Yeah.
Have you seen any genetic, you talked a lot about defense, have you seen anything from the offense side, meaning like telomere repairs, things are occurring at the cellular levels where you're actually getting, some additional benefits, not just the cognitive and defensive side?
Yeah. Well, in rodent models or humans, so we want to get into that right now. The last NEMO mission actually looked at telomere length, and I have a student that actually is interested in telomere length and longevity. it's interesting that with NASA, you can't really do anything genetic. I mean, there's so much because they want to protect the genetics of the astronauts. So I didn't even try to get that in, but that'll be like something that I'll be doing on myself. And you might be aware of the twin study that NASA did that showed that instead of telomere shortening, which they expected in space, there was actually a slight telomere lengthening of the twin that was in space. And I believe that was probably due to exercise and nutrition and just being on a routine. And I think that there's a good message in there, because even if you subject yourself to an extreme environment, if you nail down your nutrition and you actually commit to an exercise program, you could reverse and offset a lot of the age-inducing, telomere shortening things that happen in your life, like chronic stress, poor diet, not sleeping, just, an altered metabolic state, or, impaired metabolic parameters like high glucose and high C-reactive protein, these things can all contribute to oxidative stress. And so what we're really focused on is looking at inflammation, oxidative stress, which will influence our genetics, our epigenetic effects. So these are things that we're steering more towards and focusing on now, and just aside from the metabolic parameters. That's a good question. Yes?
I didn't see it represented in your slides, but some of your terminology leads me to think that perhaps there's application with fibromyalgia.
Maybe. That's kind of a tricky. I've had a couple people contact me. Some of them have contacted me because the diet has worked for them. So as an autoimmune disorder, it's really tricky. And the ketogenic diet, I'll say this, is in part an elimination diet. So it eliminates some of the dietary things that may be triggering an autoimmune reaction that may be contributing to the fibromyalgia. But I can't say, if it, would be effective for that. I can just say that some feedback indicates that it might be helpful. Yeah.
Can you give like a top level idea of what that diet would be? What's a normal weekday? I mean, not every day,
Yeah.
but
So it's gonna differ depending on what kind of foods you like. So the most important thing is that you kind of stick to that macronutrient ratio. And so what you choose for your fat source will differ. Well, I can tell you what I eat, but it may not sound too appetizing. So actually this morning, so what I had like an egg yolk omelet. So I give the whites to my dogs, and I'll make like 4 to 6 egg yolks and scramble it up, and maybe put some spinach and chopped mushrooms in it, and maybe a little bit of Parmesan cheese, and I'll make the egg yolks taste better than the whites, right? So I give the first to my dogs. So I make an egg yolk omelet, and today I just happen to have, I don't always have it, but I had sardines packed in olive oil, and I had in addition to that, usually I have some kind of green. This morning I didn't, but like we have an avocado tree, so I take an avocado, cut it in half, and just sprinkle some sea salt on it, and then I'll have coffee with I have MCT oil powder. So it's the oil, and I'll put like 2 scoops of that into the coffee, and right there, that would be a pretty strict ketogenic diet, like even more strict than the modified ketogenic diet. And if I eat that, what I would see is that my ketones are generally kind of low in the morning, about 0.4 or 0.5. But if I eat that, and by the time I get to work and settle in and everything, about an hour has gone by, if I measure, I'm a full millimolar higher, so I'll be about 1.5 already by the time I get to work. So if I'm using that therapeutically to manage something, I mean, that's an example of a diet. It may not be appetizing to everybody, but and for dinner, I typically have some kind of fatty beef, fatty fish, or chicken with the skin on it, and we have a salad with usually an avocado and lots of olive oil for dressing, and then some kind of vegetable like collard greens or spinach or asparagus cooked with butter and some seasoning and things like that. So that would represent kind of like a dinner. Yeah.
Since you mentioned biology, So back in the day, it wasn't that far back, it's kind of like Keto, Quest, MCT, and maybe some liquid C8. Since those were kind of early ones, at least from what I saw, anything better out there, more efficient, better made, someone might look at?
Yeah, there are, so the two products that I've kind of recommend that I've used the most would be the Prove It product is out there, but that's network marketing.
Too, isn't it?
Yeah, it's got stevia and a little bit of erythritol in it, which is a sugar alcohol. It's kind of like non-glycemic.
Creamer, that's the main thing. A lot of people use the Quest.
Yeah.
Okay.
Yep, and they make the Keto OS product, which is beta-hydroxybutyrate and medium-chain triglycerides combined. That one's probably the best one. And then Ketogenics makes a product called Prime, and it's got beta-hydroxybutyrate and medium-chain triglycerides and things like tyrosine and lysine and alpha-GPC and some other neurocognitive factors in there. And then our company, Ketone Technologies, which just formed, is really focused because we were a little frustrated with other companies out there, like they kind of cut corners and do some things. There's some pretty good products out there, but we want to develop a product that is really based on science. We don't have a product yet, but that we're in the development stage of vetting out, seeing what works and what does not work based on the products that are already out there, and partnering with NASA and special operations to test some of our formulas out in the field. And using that data and the data we get in the lab to develop the optimal product, maybe for more, NASA relevant applications first, but eventually that would evolve to consumer-based products. And that optimal formula has not been kind of discovered because it's such a new field. We're right on the cusp of kind of understanding what's the optimal formula. But the Prove It product and the Ketogenic product and Ketocana. Yeah.
Type 2 diabetic, also a stroke survivor. So, I see the benefit of type 2 diabetes, obviously.
Yeah.
But has there been a study for stroke survivors, or what the benefit is of a keto diet for stroke survivors?
Yeah, that's a good question. No, there hasn't to my knowledge. But there is work that has been published back in the 70s, 80s, and 90s by a group, and I've connected with that group, that used a ketogenic substance called 1,3-butanediol. And we actually use this substance to make the ketone ester. 1,3-butanediol by itself, when you consume it, it's like a dialcohol, so it kind of makes you a little bit buzzed, and that's why it's not like being sold as a ketone supplement. But when you could take it and add ketones to it and make a ketone ester, they use that substance, which is a little more powerful than like MCT, right? But less powerful than a and they did a number of rat studies subjecting the rats to a carotid occlusion, which would simulate that. They subjected them to hypoxia and did a battery of studies, and always showed the balance of the study showed that it was pretty remarkably neuroprotective acutely. So some of these studies were done giving ketones before the stroke, and some of them, there's a few studies that were done after. And kind of to throw a little curveball in there, the more aged the animal was, the less responsive it was therapeutically, but the young animals responded remarkably well. So it was kind of stratified. It was always a benefit, but the benefit was more if you were younger, which makes sense because the brain was more plastic. Important area of research, I think, and needs more focus on. So, and something that I would like to study if I can get that funded. But I mean, I have heard from a number of people who have had strokes who have used things like brain octane or even the Prove It ketone supplement and saying, I can walk now, I can move my hands, like I have function where I didn't have function before. So I'm getting the anecdotal reports that it's helpful. Yeah. Yes.
Is it important to find out when you're testing metabolism to find out if it's working efficiently or not before you do this and then?
Yeah, I think it's real important to just go to your doctor and to do, your blood pressure, get comprehensive, what would be a CMP, a comprehensive metabolic panel, and a CBC, just like your overall blood work to show your kidney function, your liver function, like all that's kind of normal, because when you do a ketogenic diet, it is stress to your body. Like, your body goes through withdrawal from sugar. A lot of times you go through, and then you're kind of forcing your body to burn fat. You know, you're forcing your liver to some extent to metabolize more fat. And as you know, you follow the diet, you may need to transition and kind of cut your carbs in half, and then do that for a couple weeks, and then go full keto, you know, ketogenic diet after that to transition your body, especially if you're not totally. What I find is that athletes that are kind of more metabolically flexible, I would say, or metabolically robust, when they start the ketogenic diet, they're like, oh, this is easy. They get into it. Whereas some other people, it takes a while. You know, they have a dysphoria, I guess you would say, when they transition into it. They find it hard.
So that's how you would test your metabolism? I thought there
Yeah.
was like an oxygen test you did.
Yeah, that, I think you're looking at, I think you're thinking about,
Like a resting,
yeah, you might be thinking about, you know, your metabolic cart, which shows if you're actually metabolizing carbohydrates versus fat. And so this is something that can be done in the lab, like Jeff Volek here, you know, studies that, but that would be not a typical thing. Probably the most important thing to measure is just like your glucose levels and your ketone levels, right? What may happen is that you go hypoglycemic at first, and you kind of feel a little bit unbalanced. Probably the most important thing is to actually stay hydrated and ensure that you're getting a lot of sodium. Like we're told that sodium is bad, but when you follow the ketogenic diet, if your insulin levels go low, you excrete a lot of sodium and you lose a lot of water at first.
Affect your kidneys too?
If you're dehydrated, it would, but if you're taking in, especially the first 2 to 3 weeks, to drink, I mean, you don't have to drink like, you know, 3 gallons of water a day, but just to drink extra water, because you may not even, like, you may be dehydrated, but your body is telling you that it's not dehydrated almost. And if you have a cotton mouth, which I kind of have right now, just from talking about, you know, you need to drink up. And because when you excrete more sodium, that actually makes your blood pressure go down more. I've had people with, you know, high blood pressure for like all of their lives, and they do the ketogenic diet, and they have like low blood pressure, like clinically low blood pressure, and they get what they call orthostatic hypotension. When you're in a seated position and you get back up and you feel a little bit dizzy, that's because your blood volume is low, because your hyponatremia, your sodium content. So you need to drink fluid, put salt on your salads, put salt on your vegetables, and make sure that sodium and water is coming in that first couple of weeks. And then your body will adjust, your renal kidney function will adjust to compensate for that.
So I guess the stigma of knowing going into ketosis is usually like you don't want to be in it too long because then it affects your organs. But how do you balance that?
I don't, for a normal healthy subject, I don't think that's the case. And I say that based upon there are patients that are started when they were kids, and now they still, as adults, they use a diet, and their blood work looks perfect. Their blood work looks great. And I follow the high carbohydrate diet pretty much all my life. I grew up in an Italian family, eating lots of pasta and bread and everything. And I had you know, elevated markers of inflammation even for a while. And I would say all my blood work, the important biomarkers that would indicate my overall health and metabolic health, have improved when I've been on the diet. And I have records going back from 2007 to 8 to now. And I would say, you know, I'm in my 40s, and everything has improved since I've been on it. So, you know, it should be going down. Like things should be getting worse, and things are actually getting better since I've been on the diet. So, but it's not, everybody doesn't respond, you know, the same. So you need to do, that's why you need to do blood work. Yeah.
So when you start talking about the eggs and the skin on the chicken and all that kind of stuff, I'm thinking that's all the things that we've been told not to eat.
Yeah, absolutely. Yeah.
So, and because it will raise your
It's saturated
cholesterol
fat,
and
right?
all that's terrible.
Fat.
So
Yeah.
you don't think so?
No, absolutely not. There's a wonderful talk that you can find online by a USF professor. His name is David Diamond. So David Diamond, PhD. One of his best talks, I think, were at IHMC, the institute that I'm associated with, IHMC, Institute for Human and Machine Cognition. And it's free on YouTube. It's about a 35, 40-minute talk. and it tells you, it nicely lays out the whole history of why the world thinks saturated fat is bad and why it's not. And I think that's an important talk. And cholesterol too saturated fat and cholesterol has been demonized, but cholesterol has been completely removed. If you look on like food labels now, it doesn't even list cholesterol, right? Because the USDA or our federal government completely removed it from something that we should be concerned about. So because the science accumulated, and the science for saturated fat is a little more debatable now, but now the cholesterol is not even debated. So dietary cholesterol. But saturated fat has been demonized, I'll say that, and from my perspective, there's no problem with having a high saturated fat diet. By the way, an egg yolk is mostly oleic acid, which is a monounsaturated fat, and actually they're the fats that I think should make up most of the fat in a ketogenic diet, just because our body probably prefers them. So if you were to take a sample of your fat, and just look at what's in it, it is mostly like 60% monounsaturated fat. So I feel, I extrapolate that myself and say that's kind of what the fat should be in our diet. So monounsaturated fat first and foremost, and then saturated fat, which includes coconut oil, medium chain triglycerides are saturated fat. And then polyunsaturated fats, there's omega-6 and omega-3, and you want a ratio that's a 2-to-1 omega-6 to omega-3 or a 1-to-1 ratio of omega-6 and omega-3. And that's really important because Western diets that have a ratio that's like 20-to-1 omega-6 to omega-3 is extremely pro-inflammatory and can be atherogenic and can be bad for your heart. So these omega-6 fats that are found in plant oils, refined plant oils, they get oxidized in the body and they become inflammatory to our blood vessels. And so it's really important to look at the omega-6 to omega-3 ratio, and to have it 2-to-1 to 1-to-1 would be kind of ideal. It's kind of hard to do, but it's not, if you stick to whole food sources and away from processed plant, like soybean oils and processed plant oils, it's fairly easy. Good question. Yeah. Yeah. I get that question a lot. There's a company out there that makes wines. They're called dry farm wines, and they have about 40 wines now, and like 95% of them are from Europe. And all the wines have like less than 1 gram of sugar, and they're just like wines off the shelf, but they've been analyzed. And you can drink these wines and stay in ketosis. And I didn't believe it at first, but they sent it to me to my office, where I actually drank and tested pretty much every wine in my office. I'm checking my glucose and ketones, and they had no glycemic response, and I was able to stay in ketosis for, if I just tried like my mom's wine or beer or things like that, it would kick me out of ketosis. Most of it, most of the things out there. So like a dry red wine is pretty safe. I mean, if you're doing 6 ounces, maybe 2 glasses or 12 ounces total per day, you're okay. If you're drinking more than that, then it's kind of hard to incorporate that. But 2 glasses a day, the low sugar wine is perfectly fine, and a lot of people do that.
All right, any other questions? All right, well, thank you very much. Putting online for you folks to come back and reference as well. The book, Low Carbohydrate Performance, I bought it. It's $10 on Amazon, unless you can wait till Monday and then you pay free shipping if you're Prime. So get on Prime. So there was one question I could tell you, not from an unscientific standpoint. My diet, I drink a lot of the bulletproof coffee. So for those unfamiliar with it, you can look it up. There's a lot of variations, but coffee with some ghee in it and My wife will be pleased to know that there's now a powdered MCT oil, so thank you very much for that, because she can't stand the liquid MCT oil, but MCT oil in it and heavy whipping cream. A couple of those, and your diet really doesn't change all that much. I eat a ton of bacon. Anytime I go get a steak anywhere, I tell them to imagine the most amount of butter you've ever put on a steak and bring twice of that. But, you know, so, and I do monitor my blood. I fall off the wagon, takes me a couple of days, or I fast and kind of get back on. So for what it's worth, that's just from my perspective. So we are going to put out an email. I think we've got everybody's email information correct. So we're going to send the email out once we kind of get our collective act together for the July 10th event. Now, he said 2 weeks. Here's my mandatory thing. Regardless of the outcome of what we're going to try and do, if you can't track your diet from now until July 10th, you're probably not a good candidate for the study. So track your diet. Be truthful, be honest. Nobody's analyzing it. We don't care if you had birthday cake like half of our staff today did. Just, you know, put down what you eat. So what's the name of the?
You can lose it or MyFitnessPal.
Yeah, MyFitnessPal. You guys have seen them. Where you can just put the food in there, tell them how much, and it'll calculate all your calories too, right? So have that ready to go, and then by then we'll figure out what it is that we're going to do, if anything, to continue on. So. But anyway, I won't keep you in the sauna any longer. I appreciate your patience. Thank you for helping, being patient while we work through some of the technical difficulties. And again, thanks Dr. D and Andrew. Appreciate it. So thank you very much.